Welcome to the Grid Mod Pod, brought to you by AEIC. In this podcast, you'll hear from the utility industry's top operations leaders on how their companies are working to modernize and improve our ever-evolving power grid. Thanks for joining us.
Good morning, George. Thanks for showing up today on the Grid Mod Pod. I'm very excited that you agreed to come talk about one of my favorite things, non-wire alternatives. So I got to meet George, to our listeners, at one of the AEIC's Center for Operational Excellence workshops, where we really brought together the utilities that are working with battery energy storage systems. And so during that day, George shared a pretty awesome project that I think would be great for us to hear about. So with that, George, just going to jump in and let you introduce yourself, and we'll jump into the project and kind of all the things that you've been learning and sharing with your customers and internal stakeholders.
Sure. So, Liz, thanks for inviting me to be on this podcast. My name is George Wegh. I'm Director of Protection and Controls Engineering for Eversource. We're the largest utility in New England area. We serve 3.3 million customers, Connecticut, Massachusetts, and Hampshire. So one of our main goals as a company is to work with our states to achieve their clean energy goals. And Massachusetts in particular has very aggressive clean energy goals. And they're also very aggressively looking to modernize the electric grid to meet those goals. We had an opportunity to, with the state, looking for pilot projects to find ways to use the new technology and achieve these goals. And so this project I'm going to talk about, which is Cape Cod, the very tip of Massachusetts out in the ocean, it was an excellent opportunity to use battery energy storage to achieve the goal.
Yeah, and so I guess from a perspective of why it's kind of a really exciting project for me, just to the listeners, my previous role, when I was a member of AEIC at the Distributed Energy Resource Subcommittee, we talk a lot about kind of enabling system planning and operational teams to embrace and, utilize DER. So a part of my career was how can we design and develop opportunities or projects that could be an additional tool to the toolbox when solving planning problems or requests from customers. And I'll just say from where I was sitting, it was projects really were being not asked, but really like, what are the opportunities in regards to non-wire alternatives? And so for those listening, non-wire alternatives are projects that could be a solution that do not require new wire, increased wire size, or the typical asset, increased transformer, et cetera. So when you came and started talking about the project, which is the Provincetown Battery Energy Storage Project, it was really interesting to hear all of the boxes that I was accumulating, trying to understand through the last 6 years. You guys were checking them off.
Yeah.
And then also the other part is that you're the director of the protection, so that the lead of the project was coming from the protection side, which I think a lot of us forget. That protection is kind of the Achilles heel to making these projects effectively work, and we can't lose sight of that. So anyway, that's really why I think this is a highlight. So, when you kind of dabble a little bit, but why was it considered the better alternative when building, for this project in particular?
Yeah. So if you look on the map of Massachusetts, there's a long peninsula, Cape Cod, that sticks out into the ocean. At the very tip of Cape Cod is the town of Provincetown, at the very end. And as it's a long, narrow peninsula, it gets narrower and narrower as it goes out. The very tip is actually a little bigger, that's why there's a population center at the end. So electrically, we're serving that area with, as you get out into the peninsula, a single transmission line goes to our nearest substation, which is 13 miles away from Providence. And then from that nearest substation It's a 13-mile, 23.8 kV feeder that runs out on this peninsula to the load pocket at the tip. And if you're driving out there, if you ever go on vacation to Cape Cod, you'll realize there's one way in, one way out. There's one road, and at one point there's ocean on both sides of the road, and our feeder is running along that road, overhead feeder. So reliability is a challenge. That feeder's always been historically a poor performing circuit. It's buffeted by storms. It's subject to a lot of different natural occurrences that could cause outages. And we've, for a long time, debated how to solve that problem. And one of the logical ways to do it would be to put a second feeder out there. And if you were going to do that, you would logically want to have it underground, since the existing one is overhead. That has always been a stumbling block. The cost, the permitting involved, the disruption to the natural habitat. There's a Cape Cod National Seashore that this feeder would go through. That would have to be, we'd have to get rights to dig in that area, which would be a big disruption to the community, to the natural habitat and the surroundings. So that's why, it's a very strong thought was given to, hey, why not use a non-wires alternative? Use battery energy storage that defers the need to potentially ever have to do that project. In addition, like I said, there's a single transmission line out to that area. By feeding this load pocket at the very tip, we're able to defer the need to bring in a second transmission source into that station, because that's something that we had, our planning group had looked at. There's under contingencies of losing that transmission line. We could have some voltage and some overload issues, but with the battery, we think we can mitigate those issues. We can pull the pocket together long enough to mitigate that.
And just, you said pocket, which it's a load pocket, which for our non-technical folks is a center of customers that are served by a specific part of the grid. And I think a lot of us lose sight that every grid, and I say this a lot on this podcast, is like a fingerprint. So there's no peanut butter spread solution. But this one, really kind of came to be really because as the battery energy storage projects and the costs thereof, really that cost benefit analysis, it seems like came to a cross point.
Right.
Awesome. So being the protection guy, what makes the protection systems that were used in this project unique and really innovative compared to like any traditional methods as well?
So I got to give credit to our distribution engineering group because they're very close to this area. The manager for this area had come up with this idea, and he wanted to make sure that we found a way to restore as many customers as possible. So this feeder, 13-mile feeder, is unique in that, again, it's about half the load or more than half of the load, about 5,600 customers, is in Provincetown at the very end. The rest of the customers are spread along the 13 miles of the feeder back to the substation. So we wanted to, since we have this single feeder, we wanted to ensure that we could very quickly isolate any fault, given that you have a system, you have your substation at one end, you have a battery at the other end, and you have to worry about, on this distribution feeder, things like stability, transient overvoltage. So we have to eliminate faults very quickly. But we also wanted to be able to pinpoint where that fault was and automatically restore as many customers on the feeder as possible from both ends, from the battery side and from the system side, in under a minute. So the only way to do that, and I should add that the faults, our system planning studies showed that the faults would need to be cleared in less than 10 cycles. So in order to clear a fault that fast, you would have to have a very high-speed protection system, and then we'd have to have a sophisticated restoration system to restore as many customers as possible. And so that warranted the need to develop a microgrid to complement the battery.
And so just some perspective for, the listeners. So you have a system model that had to be built. So you had to understand the assets, you had to have all of the connectivity information, and then you had to have the program to actually put the input and run the analytics to ensure that the two devices can coordinate and respond to a slew of scenarios. And so, one thing about grid modernization is just the fundamental realization that the world we came from and the world we're headed, that full visibility and device coordination was not something that was needed to really operate the distribution grids as a whole. But as our technology has evolved and we've really started to network our distribution circuits and we've tried to, created other technologies, it's really important to have the correct system model with those devices. And I guess just for, visual perspective is what you're saying when you say a fault scenario is like if there was an instance where a storm would take the wire down, this would send a shock wave, you could think about, that ultimately the breakers for the devices that clear the fault, say the things in our homes, will have to open quickly. And so when we talk cycles, we're talking like blinks of the eye, response time. So having that visibility from a model analytics perspective is a huge feat in itself. Some say it shouldn't be, but it's where we're evolving as the technology is becoming available to make that possible. And then to implement it out in the field is even a huge achievement. So I'm geeking out on it, but I'm not sure anyone else. So what has the community's response been to really, embracing this new technology and the whole idea of it?
The community has, we work closely with the community right from the beginning. And certainly, telling them that this was a site we were considering for the project, working with them for the proper location. Land is hard to come by out there, so we had to partner with them to find the right location within Provincetown. And then all throughout the process of building this, testing it, commissioning it, and now with it in service, they've been very supportive. They've realized the benefits. I mean, the good thing about it is when it works, they don't even know that it's working because they seamlessly island. So if there is that fault, and maybe just to go back to what you said a little bit, to geek out a little bit on the fault, if you have that fault, now traditional protection system, power flows one way from the substation out onto the feeder. It's easy to protect in that it's going to flow one way, and all you have to do is coordinate over current elements to protect that fault in one direction. Now you've got a source from both ends, battery at one side and substation at the other. So that fault is going to look different to the devices that would isolate it. And then once it's isolated from one end, it might still be supplied from the other end. And so that you have to anticipate for that. After we isolate this fault, we create this load seamlessly. We keep Provincetown online with the battery, again, so they don't know that there's been any interruption. And then from the battery side, we will expand using the microgrid how much load down the feeder that the battery will pick up to the faulted zone. So we have to be able then to protect for situations where what if you had a second fault and now only the battery is your source. So that's why the protection system became very complicated, because we have different scenarios with only the battery, only the system, both combined together. And then to make it even more interesting, our system can be either strong or weak, depending on whether that transmission source is in. So all of that had to be studied, both in the planning world and in the protection world, to make sure that we could come up with a protection scenario or protection scheme and settings that cover us for proper fault isolation barrels.
George, the project executed, it's implemented, what benefits have you seen from this particular battery energy storage project?
Yeah, sure. So the project's been in service approximately 2 years, and it's operated automatically for events upward time. And in those events, before we developed the project and we proposed it to the Massachusetts DPU, we said we expected an 80% reduction in customer minutes interrupted. And with these events, have achieved 91%. So it's been very successful. It's been seamless in picking up the Provincetown load pocket, no voltage dips at all. And we've been able to automatically resynchronize the load pocket to the grid after the fault has been repaired and stored automatically multiple times. So it's been very successful.
Right, I guess, and a big part of grid mod too is really understanding, okay, you have all this new technology, you have all of this new capabilities that, those from the outside looking in are like, well, how come it's not being utilized? And a big part of grid mod is the people and really understanding the processes. So, your team, and I like to kind of think about it, the answer is always in the room of those that are very connected to a project. Y'all want to go out and find the answers elsewhere, but I think, there's a special building that will occur when you're actually solving problems that have not been solved before. And so it seems like, having this experience and being able to take that into other projects is probably a huge benefit to implementing your first project, but also, for others in the industry to learn from. So thanks again for sharing. So I guess I'll just say, what were some of your major lessons learned, kind of trickle through, think through to share with others?
Yeah, we had numerous challenges throughout the project. I will be upfront and say that battery energy storage technology is still a new technology. There's new and changing vendors. The vendors are changing products. There's new versions. There's new firmware. And so we kind of struggled with that a little bit. We chose a vendor. That vendor then decided to exit the market and was bought by another vendor. So that vendor, we were working with a new vendor mid-project who was not the designer of the technology that we're using. So we had to work closely with them to understand what we were seeing in the simulations. We had to do some revisions to firmware and settings to get the system to perform the way we needed. So we had to work very closely with them, and that was definitely, and we still are to this point, working very closely with them, because as the battery has been in service now for 2 years, it's been in service, there have been issues and continued issues with how it responds to faults, as well as issues internally within the battery system that may take parts of the battery system offline. So equipment issues, inverter equipment issues that we've had to work with the vendor to get resolved, get the battery back online. So that's been a big issue. I would say, if you're asking lessons learned, another key lessons learned is that we have to have remote access to the facility. This facility is remote on our system. It's not easy to get to. And when something goes wrong, especially if the battery is islanding and it's the only source of supply for these customers, and it has roughly between a 3 and 10 hour total discharge time. So the clock is ticking when we're islanding. We want to make the repairs, get the customers back. But then if there's some issue with the battery that we're having problems with, we need to get quick answers and quick response. So having remote access, not only for us, but for our vendor technical experts to get in and take a look at what's happening with the batteries. So that was a big issue. I would say the other thing was the fire protection for the battery. So our battery is a little bit unique. Going back to working with the town and the community, we put the battery in a building. So we have a custom designed building for this battery versus a containerized solution, which is typically, I think, what you're seeing most utilities do in the industry. So it is in a custom built building with customized fire protection and suppression systems. And when we were in the middle of design battery project, Arizona Public Service had a big event, battery fire and accident, near fatality. And the industry kind of, we took a pause along with the industry, and the NFPA standards changed, and we changed our fire protection design over the course of the design cycle to incorporate deflagration system into the fire protection scheme so that we ventilate the building, eliminating pressure before it builds up to try to suppress the fire. So those are some of the things that we learned along the way.
Yep. And I'll just say, so when we got together, we were, with the utilities talking about our experience of implementing BESS, a big takeaway, and I think it goes back to the people and the processes, and really, as an industry and as we want to really embrace and enable and transform the grid to have the new technologies within it, it really, after the vision and the plan and the technology is available, even if it's new, there's a lot of work that internally has to happen to embrace. And so I just what we talked about, for those 2 days was just the general standards and requirements. So every utility that is going to embrace this new non-wire alternative approach or have a new tool in the toolbox, the people have to really create, a set of standards and requirements for the full project, not just the specific device. A big part we also talked about was the safety, as you mentioned, that was one of your big takeaways. There's a significant newness to it. So understanding all of the safety protocols and really awareness of what could happen, and then building that into your workforce. The big one I think we talked a lot about, right? And I think you've dealt with was the system integration. So being a remote device, having all this information out there, how do you tie it into the mothership? And then how do you operate it from that remote perspective while maintaining cybersecurity? I mean, I could go on. Then your big part was the vendor, right? I guess when I hit on this point, we think about where we were, right, George? Like the utilities themselves were they designed, built the assets that they ultimately put into the grid and then were required to operate, maintain. And so into the 1970s, though, we started giving that over to the vendor community to build these systems or these assets that work in the system at scale, which then kind of left a lot of the utility folk to really have these partnerships with these vendors because it's their devices, et cetera. So here you have a whole new set of vendors developing this asset, the battery energy storage, which I guess fun fact, when we think battery energy storage, it's not just a battery that you think that you put in your car, right? It is a fleet of many pieces of equipment that integrate into the grid. So we're not just talking about the specific inverter, it's everything, right? And I guess I can keep going. You got your maintenance, you have your planning, you have distribution, and really just the overall system project requires many groups within the utility to kind of get aligned and effectively execute on the project. So I guess, coming back to you, being the one that kind of had the project and really the technical phenomenon, what was that really the change management or really the engagement of your team? Any words of advice to those that are embarking on this, if it's a new project or a new asset in their
Yeah, sure. We had a team to put together that involved system planning, first and foremost, doing the design work. We had a protection group. We had our substation technical group, telecom group, as well as, of course, distribution engineering was at the forefront, also the whole design process. And then we had to involve the field communication field engineering group that actually does the testing and then the maintenance of the field devices. This was completely new to them. Normally they're used to, again, very simple pull top recloser type devices. And here we have pull top reclosers that are in the microgrid that are voltage sensing on both sides, can do synchronization, and are connected with fiber, talking to a mother controller at the battery energy storage. So it's a whole new world for field resources. So we had to do we had them involved along the way. Every time we had to do training, we had to bring in the vendor to do some training. Our station operations people who are in charge of station maintenance never had a facility like this before, so they had to get familiar with it. What you can do, what you can't do. what the scheduled maintenance is, the safety protocols for dealing with it. And that's an ongoing process. And like I said, we're 2 years in. I will say we're 2 years in, and one thing that has come up, again, in the lessons learned category, is some of the routine things that we do on our distribution system, switching, taking a piece of equipment out for maintenance, bypassing it so that you can take it out and work on it. We have to think through those things because in some cases we actually, we had some events happen, inadvertent events, because someone did what they would always do on the distribution system. And because everything's tied together in a microgrid and talking to each other and dependent on each other. If I take that device out, if I pull the fiber connections out of that controller, closer 1, 2, 3, all the other reclosers are like, wait a minute, there's something wrong. They may act inappropriately or unexpectedly, I should say. So we had to learn from some of these events. What are all the possible scenarios that could happen? And then in many cases, build in with logic settings and in some cases, just operational procedures, changes to how we do things on this feeder to protect against having these inadvertent events. So it's a group effort. I'll say the other group that was very involved and still is very involved, and it's a big reason for the success of the project, is they were very interested in it, was our system operations control people that operate the system. So they were very interested in this microgrid and the battery. We had a complete operations guide developed for them with all the way how you can operate it, how you can't operate it, the modes it can be in, training on it, and then they took a very active role in reviewing that, commenting on it, and we've improved it over these 2 years based on some of their observations. So
just for the listeners, what George explained was almost every group within an operations domain. It needs to be engaged. And I think it's just really invaluable because you don't know what you don't know, especially if you're trying to support, develop, create partnerships with the utilities as we embark upon this transformation, because we're in it. It's really invaluable to understand the full system and really approach, the solution with that system thinking instead of the very siloed, agenda of one specific component. I just love that you explained it. And I would even say on top of the whole operation fleet of resources, being aware is you have your procurement changes, you have your regulatory team, you have your communications team, all need to be a part of, enabling new technologies. And I think I want to lead off this podcast that this is a solution that has been executed. It's a continuous improvement perspective, it seems, and you're going to take that into all of the other projects and really all projects that you do at Eversource. So it's incredibly valuable to share just that we can do hard things, the electric utilities. We always have. We just need to have the partnerships, the right conversations, and just awareness of the type of work that is required to really execute these complex projects. Well, with that, I always like to, hopefully there's some future utility employee out there or maybe engineer kind of like wanting to learn about the power grid. So George, from your, career and your work in this field, what's advice for any of those new maybe potential engineers or workers out there about the electric utility that you'd want to give?
Okay, how much time do I have?
Love it.
So, I'm very enthusiastic about this type of question because I've been doing this a while. I've always loved this field, but what's going on now is really game-changing and super exciting because the grid is evolving so quickly. We're seeing it in New England. I think everybody's seeing it, and it's very challenging. The integration of renewable resources, which are information-based, and then that's what this battery project is. It changes the landscape of how we design the system, how we have to design it, how we have to protect it. And but for the protection and control people, we kind of have to throw we still have the old text. We have have to rewrite a new chapter of it. And we don't know the answers yet for what that chapter is going to say, because as we move to a higher and higher penetration resources, it's going to change how much fault current we have. It's going to change the type of fault current and where it's coming from. And all of those things are going to require us to adapt our protection systems so that we can still detect that fault, isolate that fault, and prevent a blackout. So if we do our job right, we won't get any credit because the lights stay on. So that's the great thing about this job. If we do it wrong, we be in the spotlight. So, but it is a super exciting time because we have new equipment, technology, we have microprocessor-based devices that are incredible, all kinds of things. But at the same time, we're being challenged very quickly by the changing makeup of the grid and to use these new technologies in ways that have never been thought of before. So it's definitely not an old business. I think young people should want to work.
Thank you again for showing up, and I look forward to being on this journey with you, George, and as we empower the next set of engineers out there. So with that, thank you.
That's a wrap for this week's episode of the Grid Mod Pod. Thanks for tuning in. We hope today's conversation got you thinking about new and creative ways to improve our power grid. Be sure to subscribe to our YouTube channel to be the first to hear new episodes. This podcast is brought to you by AEIC, the place where operations leaders come together to share knowledge and provide guidance to the electric utility industry. We'll be back with a new episode soon. Until then, keep powering on.